Presenting our podcast, Got Milk, the Indian Dairy Context, brought to you by Shunya Agritech, India's first animal nutrition and well-being focused organization. Say hello to your host, Garen Sahewal.
Welcome back to the Deep Dive. Today, we are looking at a term that usually makes my eyes just completely glaze over.
Oh, I think I know which one you mean.
Yeah, the bioeconomy.
Right.
It sounds like, something from a Silicon Valley pitch deck, like biofuels or lab-grown moss or something.
A lot of buzzwords.
Exactly. But we aren't talking about tech today. We're stripping this back to the absolute basics of survival. We're talking about the engine room of the food system.
It's funny you say that because bioautonomy does sound very futuristic, but it's actually the oldest economy in the world.
Right.
It's just energy conversion. Sun hits grass, animal eats grass, human eats animal.
Sun to grass to animal to us. And we spend so much time analyzing that final step of the chain.
The human part.
Yeah, the human food security part. We look at grain prices, we look at the meat aisle in the grocery store. But I realized reading the research for today that we almost never talk about the step right before that.
Feeding the feed.
Exactly. If you consume dairy or meat, you are part of a system where something else has to eat first.
Right.
And in sub-Saharan Africa, the demand for animal source foods is just exploding.
Yeah.
I mean, the forecast here is staggering.
It really is. The projections suggest that globally, demand for food, feed, and fuel will increase by roughly 154% between 2015 and 2050.
Wow. 154%.
Yes. But in sub-Saharan Africa specifically, it's even more intense. You have massive population growth, sure, but you also have rapid urbanization.
Right.
And a rising middle class that naturally wants more protein.
So millions of people want more milk, more meat, eggs. But here's the problem we're looking at today. Does the land actually have the capacity to feed the animals that feed the people?
That is the billion-dollar question for the listeners today. And to answer it, we're looking at a really fascinating study by Ferval and colleagues published in 2024.
Right.
They focused on two very different countries to give a sort of comparative view. Ethiopia in East Africa and Burkina Faso in West Africa.
And what I liked about this study is that they didn't just go to a few farms with a clipboard. They zoomed way, way out.
Way out.
They basically tried to balance the national checkbook for livestock calories.
That's a great way to put it. They calculated the energy balance. On one side of the ledger, you have the supply side.
But the land is growing.
Exactly. What is physically growing out there? On the other side, you have demand. What do the cows, the sheep, goats, donkeys, what do they actually need to survive?
But how do you even measure that at a national scale? I mean, I can't imagine they counted every blade of grass.
No, they didn't. For the supply side, they used remote sensing. So satellite data at a 300-meter resolution.
That's pretty detailed.
Extremely detailed for a national scale. From space, they estimated the biomass production. Literally the amount of green stuff growing on every single 300-meter pixel of land.
Okay, so satellites for the grass. What about the demand side?
For that, they built a massive data-intensive model. They used a 10-kilometer resolution for this. They took census data for livestock, millions of animals, and calculated their calorie needs based on their species, their age, and even how much physical activity they get.
So we are mapping the menu here. Let's look at the supply side first, because the contrast between these two countries is pretty extreme.
It's night and day. You have the Ethiopian highlands, which are these lush, high-altitude regions, very productive.
Yeah.
And then you have the Sahelian zone in Burkina Faso, which is semi-arid, right on the edge of the Sahara Desert.
The numbers in the study blew my mind here. In the Ethiopian highlands, the land generates about 8.6 tons of dry matter per hectare.
Just to pause there for a second, dry matter is the standard unit of measurement here.
Oh, right.
It basically means the weight of the plant material if you took all the water out of it. It's the pure nutrient content.
Got it. So 8.6 tons of pure food per hectare in Ethiopia. But in the Sahel in Burkina Faso, it drops to 1.02 ton.
An eightfold difference. It really shows you the sheer inequality of geography.
Yeah.
But here is where it gets interesting. It's not just about the amount of food. It's about what that food actually is.
This was my big aha moment in the reading. In Burkina Faso, in those pastoral areas, the animals are mostly eating grass. 94% of their energy comes from grazing.
Living off nature.
Exactly. But in the Ethiopian highlands, the menu is totally different.
Correct. In the highlands, nearly 38% of the energy for livestock comes from crop residues.
Crop residues. Now, that sounds very technical, but we're essentially talking about trash, right?
Well, agricultural byproducts.
Mhm.
Stalks, leaves, straw, parts of the plant left over after humans harvest the grain.
So it's like I eat the corn, and the cow eats the corn cob and the stalk.
Exactly. And this is actually the definition of a tight, efficient bioeconomy. Ruminants, animals like cows and sheep, are incredible because they have the stomach bacteria to digest that fibrous material that humans absolutely can't eat.
Right. We can't digest stalks.
No, so they turn that trash into high-quality protein like milk.
But that creates a really weird dependency, doesn't it?
Yeah.
In Ethiopia, the animals aren't just roaming free on the open range. They're basically waiting for the human harvest.
Yes. It links the animal survival directly to the farmer's crop success.
Wow.
If the crop fails, the human goes hungry, and the cow goes hungry. There is no buffer at all.
And speaking of buffers, we have to talk about seasonality. Because nature isn't a supermarket that's stocked 24/7.
This is a critical constraint, especially in Burkina Faso. You have a wet season where things are green and growing,
Yeah.
and then you have a very long, harsh, dry season, basically from October to June in the Sahel.
And the study quantified this feast or famine dynamic, right?
They did. They estimated that during the wet season, animals can utilize about 55% of the available biomass.
Right.
But in the dry season, that utilization rate drops to 33%.
Why such a big drop?
The grass dries out, becomes tough, it loses nutritional value, or it just gets trampled into the dust and ruined.
So you have a supply chain that completely collapses for half the year.
Essentially, yes.
And I noticed Ethiopia has its own complex seasons too, right?
Yes, very different from the Sahel. Ethiopia has complex rainy seasons. They call them the Bega, the Belg, and the Kiremt.
Right. Bega, Belg, Kiremt.
So their supply fluctuations are a bit more nuanced than a simple wet-dry binary.
Okay, so that's the supply. The grass, the stalks, the seasons. Now let's look at the demand side. The actual cost of living for a livestock animal.
The currency the researchers used here is the megajoule, MJ.
Which I'll admit sounds like a superhero energy blast.
It does, but it's just a standard measure of energy, like a calorie count.
Right. And just like us, animals have a baseline requirement just to stay alive.
We call that maintenance.
Maintenance.
Breathing, pumping blood, digestion, basic movement. For most animals, this is the biggest expense on their daily energy credit card.
But then you have the extras, and I was really surprised by how expensive these extras are.
Take lactation, for example. In the Sudanian zone of Burkina Faso, a lactating cow needs about 88.5 megajoules per day.
88.5 just to produce milk.
Yes, that is a massive energy drain. If she doesn't get that specific amount of fuel, she physically cannot produce milk. The biology just stops.
But here is the stat that really stuck with me. We tend to think of livestock just as food, meat and milk. But in Ethiopia, they are heavy machinery.
Craft power.
Plowing.
Yes.
The study found that a working bull in the Ethiopian highlands needs 106 megajoules per day.
106.
That's significantly more than the lactating cow.
You have to visualize what these animals are actually doing. They are dragging heavy wooden plows through dense, often clay-heavy soil.
For hours.
For hours at a time in the hot sun. They are the tractors of the highlands.
And if you don't fuel the tractor...
You don't plant the crop, and if you don't plant the crop, you don't get the grain for the human family.
Oh, and you don't get the stalks for the bull to eat next year.
Exactly. It's a completely closed loop. If the bull is too weak to plow, the whole agricultural system grinds to a halt.
That really drives home why this energy balance stuff matters.
Yeah.
It's not just about, is the cow skinny? It's about, will the farm literally survive the year?
It is existential. And just as a quick side note on the species breakdown, they tracked everything. Cattle, sheep, goats, horses, donkeys.
Did they track camels?
They did, but interestingly, they excluded camels from the main requirements in Burkina Faso.
Why?
Because they made up less than 1% of the population there, so it didn't statistically impact the national model much.
Ah, okay. Makes sense. So, let's play accountant for a minute. The researchers took this remote sensing supply map, and they laid it right over the data-intensive demand map.
Right.
Where did the red lights start flashing? Where is the national feed account overdrawn?
They identified these scarcity hotspots, and the first one is actually very counterintuitive. It's the Ethiopian highlands.
Wait, the place with the lush 8.6 tons of food per hectare? The most productive place is the most starved.
It sounds totally wrong, doesn't it? But it comes down to density. The Ethiopian highlands are packed. You have extremely high human population density, which means high animal density.
Too many mouths at the buffet.
Precisely. Even though the buffet is huge, the line is out the door. Because so much land is devoted to growing crops for humans, there is almost no open grazing land left for the animals.
Ah.
That's exactly why they are so heavily dependent on those crop residues we talked about earlier. They're living right on the margins.
So what about the other regions? I assume the Sahel and Burkina Faso is a hotspot.
It is a prominent deficit hotspot, yes, but for the opposite reason. It's just resource poor. The data show that in 2016 and 2017, the feed adequacy there dropped to just 62%.
62%. So the animals were getting barely over half of what they actually needed.
Right, meaning they were essentially below maintenance levels. They were getting enough to barely stay alive, but not enough to grow, work, or produce milk. They were in a state of starvation risk.
That is brutal. Were there any other deficit areas?
Yes, the northern mix zone in Burkina Faso was another big one. It met only 58% of requirements locally.
58. Why so low there?
The demand side drove that one. They have very high milk yield requirements there, which pushes the energy needs through the roof.
Now, I want to challenge the map a little bit here. I was looking at the data, and there are these big regions like the Ethiopian lowlands that show a massive surplus.
Yes.
They're bright green on the map. So why don't farmers just move their herds down there? It seems like an obvious fix.
That is what I call the surplus mystery.
Okay.
It looks like a free lunch from a satellite, but on the ground, it's actually a trap.
A trap. How?
Well, first, those areas are empty of people and animals for a very good reason, disease. You have malaria affecting humans, and you have trypanosomiasis affecting the animals.
Trypanosomiasis. That's sleeping sickness, right?
Exactly. It's spread by the tsetse fly.
So if you move a highland cow down to the lowlands to eat the extra grass, the tsetse fly just kills it.
Highly likely, yes. But even if the cow somehow survives the bugs, there is a major problem with the grass itself.
What's wrong with the grass?
The dominant species down there is called Hyperrhenia rufa.
Catchy name.
Very. It grows incredibly fast, which is exactly why the satellite sees all this lush green biomass, but it becomes woody and tough very quickly.
So it's like trying to eat a 2x4 plank of wood.
Right. It has extremely low digestibility. So the satellite looks down and says, hey, food. But the cow's stomach says, I can't digest this.
Wow. This actually brings up a really important point about this kind of big data research. The researchers were surprisingly honest about the known unknowns in their models.
There has to be uncertainty. Modeling the metabolism of an entire nation is incredibly messy.
And the biggest wild card in this whole study was something called browse.
Browse, yes.
That's animals eating leaves off trees and bushes, right,
Mhm.
instead of grass on the ground.
Yes. Goats, sheep, they all browse. The problem is satellites are great at seeing flat grass, and they are great at seeing dense forest canopies. But they are terrible at seeing how many edible leaves are on a specific thorny shrub, or how reachable those leaves are for a hungry goat.
The margin of error they gave for this was huge. They said the utilization rate for browse could be anywhere from 5% to 38%.
That's not even a margin of error, that's a guess.
Yeah.
And it completely changes the conclusion. In the Ethiopian Midlands, if the animals are actually eating 38% of the leaves, the deficit might not be that bad.
But if they're only eating 5%,
Then they are in deep, deep trouble. It is the single biggest source of uncertainty in the entire model.
it's kind of funny, honestly, that for all our AI and multi-million-dollar satellite technology, we still don't really know what a goat is doing in a bush.
Animal behavior is notoriously hard to model. And there was another fuzzy number they mentioned, milk yields.
Right. If the model assumes a cow is producing, say, 2 liters of milk, it calculates a really high energy demand.
Exactly. But if that cow is actually only producing half a liter because of poor genetics or because it's slightly sick, the model is overestimating the hunger.
Because it thinks the cow needs fuel for milk it isn't actually making.
Right. It thinks the cow needs way more food than it does.
So the situation might actually be slightly better than the scary red map shows, simply because the animals are underperforming.
Yes. Which is a pretty depressing silver lining if you think about it.
Yeah, good news, we aren't starving quite as much because we aren't producing any food.
Exactly.
So we have these intense hotspots. We have an agricultural system that is clearly pushing its limits. Demand is skyrocketing.
Skyrocketing.
What are the solutions? Because simply telling people, hey, stop eating meat, that isn't a realistic policy for developing economies where people desperately need the protein and the micronutrients.
No, it's not realistic at all. The paper breaks it down into demand-side and supply-side solutions. Let's look at the demand side first. The most effective, but arguably the most painful solution is destocking.
Selling off the animals.
Right. But doing it early. Encouraging farmers to sell their animals before the dry season or a drought hits?
Treating the herd like a bank account.
Exactly. You withdraw the cash, you sell the animal before the market crashes due to the drought, and the animal loses all its weight anyway.
But that has to be so hard for a farmer. That animal is their savings. It's their social status.
It is.
And if everyone sells at the exact same time because a drought is coming, the price crashes anyway, right?
Well, which is why it requires really functioning markets and a massive shift in cultural mindset. It's tough. The other demand-side fix is genetics, focusing on quality over quantity.
Building a better biological engine.
Right. If you have a local breed of cow that produces 2 liters of milk for a certain amount of feed, and you can introduce a crossbreed that produces 10 liters for that same energy input.
You can keep fewer animals on the land, but get the exact same amount of food for the humans.
That's the idea.
Yeah.
Quality over quantity.
Okay, so what about the supply side? We talked about how crucial those crop residues are in Ethiopia, the stalks and the straw.
The low-hanging fruit there is storage. It sounds a bit boring, but it's absolutely vital.
How so?
Right now, a lot of those residues are just left sitting in the field after harvest. They get rained on, they rot, termites eat them, or they just get trampled by wandering herds.
So the energy is physically there, it's just being wasted.
Exactly. If you can train farmers to store them properly, keep them dry, stack them effectively, you save that vital energy for the lean times. It's the cheapest way to increase your supply.
Makes total sense. And what about trade? We saw some green areas on the map, like the southern mixed zone in Burkina Faso. Can't we just truck that surplus food to the starving animals in the north?
In theory, yes. You could move feed from the southern mix zone up to the hungry Sahel, but you have to think about the logistics.
The road.
You need roads, you need trucks, you need diesel fuel. Hay and grass are very bulky, but they are cheap, so trucking them long distances becomes economically unviable very fast.
It costs more to ship it than the hay is worth.
Exactly. It changes the economics completely.
Now, there is one last connection I want to make here before we finish up, and I think this is crucial for you, the listener, who might be thinking, why should I care about the dietary needs of a cow in Burkina Faso?
There is a massive climate angle to this entire discussion.
Right. And it's really counterintuitive. Usually, we just hear a single equation. Cows equal methane, methane equals bad.
Right.
So intuitively, fewer cows or starving cows should mean less gas, right?
You would think so, but biology is tricky. When a ruminant is starving what the researchers call sub-maintenance feeding,
Okay.
it is still producing methane. It's burping greenhouse gases just to stay alive, just from basic digestion. But it is producing 0 meat and 0 milk.
So it's essentially 100% pollution intensity.
Exactly. The emissions intensity, which is the amount of gas per kilo of food produced, goes straight through the roof.
Because the denominator is 0.
Right. If you feed that animal better, so it meets its energy balance, it grows faster, it works harder, it produces milk, and the emissions per unit of output drop dramatically.
So, ironically, feeding the cow more and feeding it better is actually the climate-friendly move.
In these specific systems, absolutely. Better feed balance equals lower emissions intensity. Efficiency is mitigation.
A healthy, highly productive animal is much better for the planet than 3 starving ones that produce nothing but gas.
That is exactly the point.
That is a really powerful takeaway. So let's wrap this deep dive up. We looked at how satellite data and big data models help us see the invisible hunger of livestock in Ethiopia and Burkina Faso.
We did.
We found that the most lush lands are often the most overstretched due to population density. And we found that it's a very delicate balance between expanding croplands for humans and maintaining grazing lands for animals.
The main takeaway is that the waste from human crops is becoming the absolute lifeline for livestock. We are moving toward a world where human food and animal feed are inextricably linked through these residues.
Which leads me to a final thought that's been nagging me since we started talking about the corn stalks and the straw.
What's that?
Well, plant breeders and geneticists around the world are constantly working to create better crops for humans.
Yes, higher yields.
But usually, better means dwarf varieties, shorter stalks.
Oh.
Because they want the plant to put all its biological energy into the grain, the ear of corn, and less into the stem.
Right. That was the entire basis of the Green Revolution, maximize the grain output.
But if the livestock system in places like the Ethiopian highlands is roughly 40% dependent on those very stalks,
Yes.
and we replace all the traditional crops with these new dwarf varieties to feed the humans.
You solved the human hunger for bread, but you might inadvertently starve the tractors.
The bulls that plow the field.
Exactly. You are removing the energy source for the draft power.
We might be engineering an agricultural collapse without even realizing it, just by shortening a stalk of wheat.
It is a classic bioeconomy dilemma. You really can't just optimize for the seed anymore. You have to optimize for the whole plant because in this kind of tight system, nothing goes to waste.
The stem is just as important as the seed. That is definitely something for you all to chew on today. Thanks for diving deep with us.
It was a pleasure to be here.
We will see you next time.
Hope you enjoyed this episode of Got Milk, the Indian Dairy Context. Subscribe to the podcast. And a reminder, this episode was brought to you by Shunya Agritech, India's first animal nutrition and well-being focused organization. Thank you, and see you in the next episode.